My entry for the Audio Engineering Society and Matlab Plugin Competition is a simplified model of the Boss DS-1 distortion pedal. This audio effect is usually used on acoustic and electric guitars, but it can also be used on drum elements such as kick drums or snares to filter and distort the incoming signal. The guitar pedal is made up of 5 important stages. The first one is the input buffer. This applies some frequency filtering and also boosts the signal using a transistor. The next stage is the operational amplifier gain stage. This stage applies some more filtering and boosts the signal even more. Next, the clipping section. This is made up of 2 parallel diodes. This system limits the input voltage that is coming from the 2 gain stages. Next, the tone control stage that is made up of 2 filters, one high pass and one low pass filter, with a tone control knob that blends between the two. Finally, the output buffer removes some more unwanted frequencies and also removes the DC component. The development of the program started by analyzing the behavior and the schematics of each section. Furthermore, each stage has been implemented in the SPICE simulation software. This is the input buffer stage, the operational amplifier gain stage, together with a parallel diode system, and finally the tone control stage. The transistor buffer stage, together with the operational amplifier gain stage, can both be discretized using filters. Using a combination of analyzing the frequency response of the simulated circuit to find the poles and zeros, together with nodal analysis using Kirchhoff and Ohm's law, we're able to write down continuous time transfer functions for each stage. Next, using the bilinear transform, discrete time coefficients can be found. These can be further used for a digital filter. Testing had been done against the frequency response representation of the real analog pedal and also against the frequency response of the simulated circuit. This is the transistor gain stage. Next, the operational amplifier stage, the MATLAB digital implementation, the simulated circuit, and the real analog pedal. Next, the clipping stage. Diodes are usually used to limit the voltage that exceeds a certain threshold. Due to limited computational power, their behavior cannot be mapped exactly, so an approximation will be used. This function is an approximation of the hyperbolic tangent, and the behavior can be seen in figure 9. Finally, the tone control stage is made up of 2 filters, one high pass and one low pass. These 2 filters have fixed cutoff frequencies that can be determined by doing nodal analysis and taking the values of the resistance and capacitance, or by analyzing the frequency response of the simulation as done for the first stage. More testing was finally done by comparing the frequency response and time domain representations of the digital implementation and the simulation. Next, I will demonstrate the use of the plugin on some acoustic guitar.